CFA Level 1 Practice Questions. Learning Module, Simple Linear Regression. Topic, Prediction and the Simple Linear Regression Model. An analyst estimates a regression of net profit margin, NPM %, on fixed asset turnover for a sample of firms. The regression equation is NPM equals 0.6 plus 0.3 times photo plus epsilon. The predicted net profit margin for a firm with a fixed asset turnover of 4 is closest to A. 1.8%, B. 1.2%, C. 2.4%. The change in predicted NPM when photo increases from 2 to 5 is closest to A. 0.6%, B. 0.9%, C. 1.5%. If the retailing index decreases by 1.0% next month, the expected Aurora return is closest to A. 0.0063, 0.63%, B. 0.0115, 1.15%, C. 0.0167, 1.67%. If a company has an interest coverage ratio of 4, the predicted debt-to-equity ratio is closest to A. Negative 0.170, B. Negative 0.190, C. Negative 0.190. Is the relationship between the interest coverage ratio and the debt-to-equity ratio significant at the 0.05 level? A. No, because the r to the power of 2 is less than 1.0. B. No, because the p-values of the intercept end slope are less than 0.05. C. Yes, because the p-values for f and t for the slope coefficient are less than 0.05. Based on Exhibit 1, the sample covariance between the debt ratio and the short interest ratio is closest to A. Negative 30.0000, B. Negative 0.5085, C. Negative 2.0000. Which of the following best describes Rivero's findings? Higher debt ratios cause lower short interest ratios. B. Higher short interest ratios cause higher debt ratios. C. Firms with higher debt ratios tend to have lower short interest ratios. Based on Exhibit 2, the number of degrees of freedom for the t-test of the slope coefficient in this regression is A. 58, B. 59, C. 60. Which of the following should Rivera conclude from the regression results? A. The average short interest ratio is 5.70. B. The slope coefficient is significantly different from 0 at the 0.05 level. C. The debt ratio explains 33.33% of the variation in the short interest ratio. Based on Exhibit 2, the expected short interest ratio for a company with a debt ratio of 0.60 is closest to A. 4.50, B. 5.70, C. 3.50. Based on Rivero's regression results in Exhibit 2, the F-statistic for testing whether the slope coefficient equals 0 is closest to A. 2.69, B. 7.25, C. 0.1111. Based on Exhibit 1, Patel should A. Conclude that the GDP forecasts are unbiased. B. Reject the null hypothesis that the slope coefficient equals 1. C. Reject the null hypothesis that the intercept coefficient equals 0. Based on Exhibit 1, Patel should calculate a prediction interval for actual GDP growth when the forecast is 2.5% that is closest to A, 1.73% to 3.33%, B, 2.48% to 2.58%, C, 2.30% to 2.76%. Which of Paddle's observations about forecasting is correct? A, only observation 1. B, only observation 2. C, both observation 1 and observation 2. Based on Exhibit 1, the standard error of the estimate is closest to A, 0.0512, B, 0.0471, C, 0.0843. Based on Exhibit 2 and Maria's prediction of the semiconductor index return for month 41, minus 0.02, the estimated TECH's return is closest to A, 0.0058, B, 0.0120, C, 0.0182. Using Exhibit 2, the 99% prediction interval for TECH's return in month 41 is best described as A, y hat f plus or minus 0.0521, B, y hat f plus or minus 0.1412, C, y hat f plus or minus 0.2810. Based on Exhibit 2, technique scenario, Maria should fail to reject the null hypothesis that A, the null hypothesis that the slope coefficient equals 0, B, the intercept equals 0, C, the null hypothesis that semiconductor returns do not explain technique's returns. The standard error of the estimate, SEE, is closest to A, 10.408, B, 108.330, C, 14.414. An analyst is discussing the factors that affect the width of a prediction interval in a simple linear regression. Which of the following statements is most accurate? All else being equal, a higher confidence level, for example, 99% versus 95%, will result in a narrower prediction interval. B, making a prediction for an independent variable value that is farther from its sample mean will result in a wider prediction interval. C, a lower R-squared value for the regression will result in a narrower prediction interval. When making a prediction, you must use the estimated regression coefficients and ignore the error term, which represents random deviations unique to individual observations. The intercept 0.6 provides the baseline value of the dependent variable when the independent variable is 0, while the slope 0.3 defines the sensitivity of the predicted return to each 1 unit change in the index. The predicted value is a point estimate representing the average relationship described by the regression line. It is distinct from the residual, which is the difference between an actual observed value and that predicted value. The most efficient way to find the change in the dependent variable is to multiply the slope, B1, by the change in the independent variable. 0.3 times 5 minus 2 equals 0.9. When calculating the difference between two predicted values, the intercept B0 cancels out, meaning it does not impact the final answer for a change. It is vital to distinguish between a predicted level, which requires the full equation, and a predicted change, which only requires the slope and the difference in x. Predicted return equals intercept plus slope times lagged retailing change. Lagged retailing change equals negative 0.010. This shows the expected Aurora return as 0.0167, 1.67%. Regression equation. Predicted debt to equity equals 0.210 minus 0.095 times interest coverage. At interest coverage equals 4, predicted debt to equity equals negative 0.170. This negative result reflects that firms with strong interest coverage tend to have very low or even negative debt to equity ratios. Both the slope coefficients t-test and the overall f-test have p-values equals 0.000, which are less than 0.05. This means the null hypothesis, slope equals 0, is rejected. R to the power of 2 is only descriptive and does not determine significance. P-values below 0.05 indicate significance, not insignificance. In regression, the null hypothesis is slope equals 0. With one independent variable, the f-test and t-test p-values are identical, confirming significance. R to the power of 2 measures explanatory power, while p-values test statistical significance. Since p-values is less than 0.05, the relationship is significant. Difference between the sum of cross products and the sample covariance. Sample covariance is calculated by dividing the sum of cross products of deviations, minus 30.00, by n-1, 59. Denominator. Using n-1 instead of n is required to calculate a sample statistic. The calculation result negative 0.5085 correctly identifies the joint variation per pair of observations. Regression analysis identifies statistical association or correlation, but it cannot establish causation. The phrase tend to have in choice C correctly describes this observed relationship. The relationship is statistically significant because the absolute value of the t-statistic, minus 2.69, is greater than the critical value, 2.0001. The negative slope coefficient, minus 2.0000, indicates that as the debt ratio increases, the short interest ratio decreases, making choice B's direction incorrect. Choices A and B are incorrect because the word cause overstates what can be demonstrated through regression alone. In a simple linear regression, the degrees of freedom, df, for a t-test is calculated as the number of observations minus the number of parameters estimated, the intercept n, the slope, which simplifies to n-2. The df used for the t-test of the slope coefficient is identical to the residual, or error degrees of freedom shown in the ANOVA table. With 60 observations, the calculation is 60 minus 2 equals 58, which matches the residual df provided in Exhibit 2. The core logic relies on comparing the calculated t-statistic, minus 2.69, against the critical two-sided value, plus or minus 2.001. Since the absolute value of the t-statistic is greater than the critical value, the null hypothesis is rejected. This rejection confirms that the slope coefficient is statistically significant at the 0.05 level, making choice B the only valid conclusion. The intercept, 5.7000, represents the predicted value when the debt ratio is 0, not the average return, 270, divided by 60 equals 4.5. And the percentage of variation explained is defined by the coefficient of denomination R squared, which is 11.11%, rather than 33.33%. Substitute the debt ratio 0.60 into the regression equation from Exhibit 2. The intercept 5.70 is the baseline and the negative slope. Minus 2.00 determines the decrease as the debt ratio increases. The F-statistic 7.25 is found in Exhibit 2, ANOVA table. F-statistic purpose: test the null hypothesis that the slope coefficient for the independent variable, debt ratio, is 0. F-statistic is calculated as MSR, mean square regression, divided by MSE, mean square error, specifically 60.0000, divided by 8.2759 in this case. F-statistic tests overall model fit, always positive, while T-statistic tests individual coefficients, positive or negative. R-squared measures the strength of the relationship, while F-statistic determines if the relationship is statistically significant. In simple linear regression, the F-statistic is the square of the T-statistic for the slope coefficient. Dual condition for unbiasedness. For a forecast to be considered unbiased, it must satisfy two specific conditions. The intercept, beta 0, must equal 0, and the slope, beta 1, must equal 1. Statistical decision rule. The calculated T-statistics must be compared to the critical value of 1.990. For the intercept, the T-statistic is 0.50, and for the slope, testing H0, beta 1 equals 1, the T-statistic is negative 1.25. Because the absolute values of both calculated statistics, 0.50 and 1.25, are less than the critical value of 1.990, you fail to reject both null hypotheses. This failure to reject confirms the forecasts are unbiased, making choice A the only valid conclusion. A prediction interval is built by applying a margin of error, critical t-value multiplied by the standard error of the forecast, to a predicted point estimate. The point estimate, 2.525%, is the baseline. To find the standard error of the forecast, SF, you must calculate the total variation of x by multiplying the squared standard deviation by n-1. The standard error of the forecast, SF, accounts for the uncertainty of a single observation. Applying the resulting margin of error, 0.8022%, to the point estimate yields the final range of 1.73% to 3.33%. The width of the prediction interval is directly proportional to the standard error of the estimate, C. If variability around the regression line increases, the forecast uncertainty grows, causing the interval to widen. Emphasizes that the interval is variable, not constant. It changes based on the distance between the specific forecast value and the sample mean. The further the forecast moves from that average, the wider and less accurate the interval becomes. Standard error of the estimate, SE, formula, is the square root of the sum of squared residuals, SSE, divided by the degrees of freedom, n-2. Raw data from Exhibit 1, the SSE of 0.0843 and 40 observations, to arrive at the calculated result of 0.0471. It emphasizes that using the correct divisor, n-2 equals 38, is essential for a sample-based regression estimate. To find the point estimate, you must use the full regression equation, y equals b0 plus b1 times x, with the estimated coefficients provided in Exhibit 2. The final result, 0.0058, is the net effect of the positive intercept, 0.0120, which acts as a baseline, and the negative adjustment, minus 0.0062, caused by the expected decline in the semiconductor index. Even with a negative return in the independent variable, the predicted return remains positive because the baseline intercept is larger than the negative impact of the slope. Prediction interval is the predicted value, y hat, plus or minus the product of the critical t-value, and the standard error of the forecast. For a 99% confidence interval, 1% significance, you must use the two-sided critical t-value, 2.711, rather than the one-sided value. Standard error of the forecast, SF equals 0.0521, is provided directly in the text in, is the correct term to use for a prediction interval, rather than the standard error of the estimate, SEE. Multiplying the chosen critical value by the forecast error, 2.711 times 0.0521, to find the margin of error, 0.1412. The result, 0.1412, specifically defines the range around the predicted value, directly matching option B. Point estimate context. While not required to solve for the interval structure, the explanation notes that the predicted value, y hat equals 0.0058, serves as the center point of this interval. T-statistics from Exhibit 2, 1.33 for the intercept in 3.26 for the slope. Focus on the use of the two-tailed critical t-value, 2.711, which is the correct benchmark for testing if a coefficient is significantly different from 0 at the 1% significance level. The comparison for the intercept. Because the calculated t-stat, 1.33, is less than the critical value, 2.711, the decision must be to fail to reject the null hypothesis that the intercept equals 0. T-stat 3.26 is greater than 2.711, meaning the null hypothesis for the slope, and by extension, the lack of explanatory power is rejected. Standard error of the estimate, C, is 10.408, derived from the mean square error, MSE, of 108.33. Mean square error, MSE, is calculated by dividing unexplained variation, SSE, by degrees of freedom, n-2. Standard error is the square root of MSE. Predictions are most accurate when the independent variable is near its sample mean. Increasing the distance from the mean increases the standard error of the forecast, SF, which mathematically forces the prediction interval to become wider. A higher confidence level, 99% versus 95%, requires a larger critical t-value. Because this value is a multiplier in the formula, it widens the interval instead of narrowing it. A lower R-squared indicates a higher standard error of the estimate, SEE. Since SEE is a component of the forecast error calculation, a higher SEE results in a wider prediction interval. Topic: Functional forms for simple linear regression. A functional form of a simple linear regression, in which the independent variable is logarithmic, but the dependent variable is linear, is best referred to as U, a Log-Lin model, B Lin-Log model, C Log-Log model. An analyst is modeling company revenue in millions dollars against advertising expenditure. She believes that a 1% increase in advertising will lead to a constant absolute and dollar increase in revenue. The most appropriate functional form for this regression is A linear, B log-log, C Lin-Log. A researcher is examining the relationship between a country's GDP per capita, X, and its life expectancy, Y. He transforms both variables by taking their natural logarithms before running the regression. The slope coefficient in this model represents A. The absolute change in life expectancy for a 1-unit increase in GDP per capita. B. The percentage change in life expectancy for a 1% increase in GDP per capita. C. The absolute change in the natural log of life expectancy for a 1-unit increase in GDP per capita. Lin-Log model is explicitly defined as the form where the dependent variable is linear, but the independent variable is log transformed. Log-Lin model transforms the dependent variable, while the log-log model transforms both. The naming convention follows a specific hierarchy. The first term refers to the dependent variable, y, and the second term refers to the independent variable, x. Pay attention to the fact that for financial calculators, like the BA2+, the Lin-Log model is associated with the ln natural log setting. Focus on the mathematical representation yi equals b0 plus b1 times log of xi, which is used when the analyst wants to measure absolute changes and y for relative changes in x. For this model to function, all independent variable values, x, must be greater than 0, as natural logarithms cannot be calculated for 0 or negative numbers. Lin-Log model is the correct choice because it keeps the dependent variable, revenue, in linear form, while the independent variable, advertising, is in logarithmic form. In a Lin-Log model, the slope coefficient, B1, specifically measures the absolute change in the dependent variable for a relative percentage change in the independent variable. A standard linear model is inappropriate here because it implies a constant absolute change in y for an absolute 1-unit change in x, rather than a percentage change. A log-log model is used for elasticities, meaning it would represent a constant percentage change in revenue for a 1% change in advertising, which does not match the absolute dollar increase described in the question. Log-log model, where both dependent and independent variables are transformed into natural logarithms. Slope coefficient represents elasticity, indicating the percentage change in the dependent variable for a 1% change in the independent variable. Shifts from absolute changes to relative or percentage changes due to the log transformation of both variables.